Alright, welcome folks. This video is going to go over the answers for the how likely is it practice test. Now the format for this video, on each page the answers are going to be listed. In addition to the answers being listed on each page, I will go over and demonstrate how to correctly solve all of the questions on the practice test. It's going to be your judgment if you would like to listen to the explanations on each page or fast forward until the next set of answers. Here's the first page of the how likely is it practice test. You can take a few seconds, pause the video, and double check your answers with the ones that are listed there on this page. Now that you've had a chance to check over your answers, I'm going to demonstrate where each of those answers for A, B, C, and D, and E comes from. Taking a look at the very first question, what is the probability of drawing a white chip? So I look at the chips in the container right over here. When it comes to probability, I'm looking for the total number of chips in this container, which we know by counting are 8. There are 8 total chips in this container. Problem A, I'm looking for how many of them are white. So 1 out of the 8 chips in that section are white. Therefore, my probability is 1 out of 8. Letter B, I'm looking for checkered chips. Again, I still have 8 total chips, and I'm counting up the number of checkered chips in there. I have 4 out of the 8 checkered chips. Letter C, I'm looking for gray chips. Again, nothing has changed. 8 total chips. 1, 2, 3 of which are gray. Now the last 2 questions are going to ask something slightly different. Letter D asks for not drawing a white chip. I need to look at all of the chips that are not white in this example. 1, 2, 3, 4, 5, 6, 7 out of the 8 total chips are not white. Letter E is what is the probability of not drawing a gray chip. So I'm going to look for all the chips that are not gray, and I'm going to put a red dot inside of them. 1, 2, 3, 4, 5. 5 out of the 8 chips are not gray. Again, take a few seconds, pause your video, and check over your answers for page 2. The directions for this spinner game goes as follows. You are going to spin each of the spinners. I'll label them number 1 and number 2. Once you have spun both spinners, you are going to multiply your 2 numbers together. You win if you get an odd number as a result. The first thing I look for in this problem is how many different combinations of spins can we get? To figure that out, first of all, I look at my first spinner. How many different outcomes do I have on my first spinner? 4. 1 for each of the spots on the spinner. Now I go ahead and take a look at my second spinner. Again, how many outcomes do I have on that spinner? Well, I have 3 different outcomes for the 3 different spots on this spinner. So if I have 4 outcomes on the first spinner and 3 outcomes on the second spinner, all I have to do is multiply them together to realize that I have 12 different combinations of numbers that I can get. Again, that's important to repeat. There are 12 different combinations of numbers that you can get by spinning these 2 spinners. Now, taking a look at the questions, I need to find the following probabilities. What is the probability of, when I spin 2 spinners and multiplying them together, of getting an odd number? You're going to notice my denominator is 12 for the 12 outcomes that we talked about just a few seconds ago. What we need to figure out is, out of those 12 outcomes, how many of them are odd? So here's what I did. I pretended like I was playing this game, and I started my first spin with the number 1. If I got a 1 on my first spinner, and then I spun my second spinner, and I spun it, what were the 3 numbers I could come up with? Well, if I got a 1 and a 2, I would get 2. I got a 1 and a 3 and I multiplied them together, I would get 3. And a 1 and a 4, I would get 4. And then I just moved on. 2. 2 and 2 is 4. 2 and 3 is 6. 2 and 4 is 8. Moved on to 3. 3 and 2 is 6. 3 and 3 is 9. 3 and 4 is 12. And the last one. 4 and 2 is 8. 4 and 3 is 12. And 4 and 4 is 16. Here are my 12 different outcomes for spinning 2 spinners. Now I looked back at the question, what is the probability of getting an odd? I looked up at the box up here. How many of these numbers are odd? After looking back at this, Mr. Miller realized the mistake that he made. How many of these numbers are odd? Well, let's see if we can get our black here. How many numbers are odd? Well, we have one odd number here, and we have one odd number here. So our odd numbers should actually be 2 out of 12. We're going to ignore that for just a moment. Mr. Miller got them backwards, it looks like. 2 out of the 12 combinations are odd. So if 2 out of the 12 are odd, how many of them are even? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Cross that out. Let's make this 10 out of 12. 10 out of 12 combinations are going to get us an even number. Is this a fair game? No way, Jose. 2 out of the 12 combinations get us an odd number, and 10 out of the 12 combinations get us an even number. Those are not equal, and this is not a fair game. Just remember, folks, Max says, this ain't cheesy. Probability is easy. Study for that test, get good grades, be happy. Alright, page 3. Again, take a few seconds, compare your answers with the answers that are listed here. Now, I'll demonstrate how to answer questions A and B. We'll start with letter A. Find the following theoretical probabilities. So the first thing I'm going to do is I'm going to try and split my spinner up into as equal sections as possible. Now that I have my spinner split up, I'm going to look at each of these sections. Each of my blue sections here is split into 1/4. All pieces are equal, and each of them is split into 1/4 equal sections. 3 sections of my new spinner are very easy to identify. This one that I now have shaded in green is 1/4. This part that is also shaded in green is also 1/4. I have 2 sections of the letter B that are 1/4. Those 3 are very easy to identify. We need to look at this last section to determine what our probabilities are of getting a letter A and a letter B. I'm looking at this section right up here. Now, this whole thing makes up a section of 1/4 of my whole spinner. But this section of 1/4 is split into 2 equal pieces. So splitting something into 2 equal pieces is really like splitting it into 1/2. So this section up here, I'm going to use color. This section up here is split into 1/4 equal pieces. So I'm going to take the fraction of 1/2, because they're split into equal pieces of 1/2, of the 1/4, because that's what the total area of that spinner is. Now if we remember back to our fractions unit, the word of is going to be our key here. I'm taking 1/2 of 1/4. We know that that really means multiply. 1/2 times 1/4 gets us 1/8. Each of these sections right here is 1/8. So now I'm going to go back and I'm going to look for the probability of letter A. Well, this section right here is 1/4. And I'm going to add it to this little other piece here, which we said is 1/8. So I need to add 1/4 plus 1/8. To do that, I must find common denominators. 1/4, we're going to change it into 2/8. 2/8 plus 1/8 gets us 3/8. Now I'm going to try and find the probability of letter B. Again, I'm going to go back to my spinner. I have a 1/4 section here, I have a 1/4 section here, and then I have an 1/8. So I have 1/4 plus 1/4 plus 1/8. What do I get when I add 1/4 plus 1/4 plus 1/8? Well, I get 5/8. The probability of spinning letter B is 5/8. Question B asks us, if you spun the spinner 64 times, how many times would you expect to get A? Well, we have to look at the theoretical probability of spinning an A, which we look at from the first question. We should expect 3 out of 8 times to spin the letter A. Now, if we did this a total of 64 times, 64 would be our new denominator. Now all we're doing is trying to solve equivalent fractions. 3/8 is equal to how many 64ths? We would solve this by how many times is 8 going to 64? Well, 8 times 8 gets us 64. Whatever we do to the bottom, we must do the same to the top. So 3 times 8 gets us 24. Our answer is 24 times we could expect to get the letter A if we did this altogether 64 times. Alright, the last page for the how likely is it practice test. Take a few seconds, check over your answers, and compare them with the answers that I have in the video. I'm going to take a look at letter A first. Find the following experimental probabilities. When I see the word experimental, I'm going to look for only what they did in their experiment. So I'm looking only for what happened in the table. Now, according to the directions, Mr. Dahlman rolls 2 dice together 50 times. He's then going to add the 2 numbers together. So when he added the numbers together, here's obviously the combinations that he can get. Here is how many times he got those numbers when he rolled 2 dice and added the sums. So the first question is what is the probability of getting an odd? I need to figure out how many times did he get an odd. Well, I should know from the problem that Mr. Dahlman did this 50 times. So 50 total times is my denominator because I want to know the total number of times he attempted. 50 times is the denominator. How many times did he get odd? Well, I'm going to look for every time that he got an odd. So the numbers 3, 5, 7, 9, and 11. Well, I see 4, 8, 10, 4, and 2. All of those times are odd numbers, so I'm going to add them together, and once I do, I'm going to end up with 28. So 28 out of the 50 times Mr. Dahlman got an odd. Now I'm going to look for the second part of this question. How many times did he get an even? Well, I'm going to look at how many times did he get 2, 4, 6, 8, 10, or 12. Well, 1, 3, 7, 7, 1, and 3. Add those together. 22 times out of the 50 that Mr. Dahlman did this, he got an even number. Now the last part of this question is, how many times did Mr. Dahlman roll a 2? P2 stands for the probability of getting a 2. Well, I look, how many times did Mr. Dahlman get a 2? Just 1 out of 50 times that he did this experiment that he rolled a 2. Now for the letter B, I'm going to completely shift gears here. Find the following theoretical probabilities. I pay no attention to this table and how many times he rolled something. That is the key. Do not pay attention to the information that is up here. We are only looking at how many combinations of numbers can Mr. Dahlman get. I know that when you roll 2 dice together, you have a possible of 36 combinations. You have 6 combinations on the first dice, and you have 6 combinations on the second dice. Multiply them together, you get 36 total possible combinations, which is why 36 is my denominator in theoretical probability. So here's what I'm going to do. I'm going to figure out what is the probability of getting odd. So again, I'm looking at the numbers 3, 5, 7, 9, and 11. How many ways can I make the number 3, 5, 7, 9, and 11? Now, again, we do not want to pay attention to any of these numbers. I'm going to use the table to help organize my information, but I am not going to use any of the numbers from here. So I'm looking for the number 3. How many ways can I roll 2 dice, add them together, and get 3? Well, I'm going to think in my head. I have 1 plus 2, and I have 2 plus 1. Those are the only way to make 3 when I roll 2 dice together. So I'm going to put a nice 2 here to know that there are 2 ways. Now I'm not going to go through and list out every time, but I'm going to think about this. How many ways can I make 5 when I roll 2 dice? If you need to list them out, now would be a good time to do it. I could do 1 plus 4, 4 plus 1, 2 plus 3, and 3 plus 2. There are 4 different ways to make the number 5 when you roll 2 dice together. Now I'm going to go ahead and fill out the rest of the table. There are 6 ways to make a 7. There are 4 ways to make 9, and there are 2 ways to make 11. So now, with all of my odd numbers, 3, 5, 7, 9, and 11, I figured out how many ways there are to make each of those. I'm going to add those up. 2 plus 4 plus 6 plus 4 plus 2. That gets me 18. 18 out of 36 ways I can make odd numbers. Now I'm going to take a look at trying the evens. So I'm going to look for the numbers 2, 4, 6, 8, 10, and 12. How many ways can I make 2? How many ways can I make 2 when I roll 2 dice together and add them together? There's only one way to make the number 2 when I roll 2 dice and add them together. That's a 1 plus 1. Now I'm going to move on to 4. And again, I'm not going to list all the combinations out. You should figure them out on your own. But it's 3 ways, it's 5 ways, it's 5 ways, it's 3 ways, and it's 1 way. So again, I'm going to go through and I'm going to add 1, 3, 5, 5, 3, and 1, and I'm going to get 18. 18 out of 36 ways to get an even number. Now the last question again asks us for the probability of getting a 2. There are still 36 possible combinations with 2 dice. How many ways can I make the number 2? Well, there's only one way to make the number 2 when you roll 2 dice together. That's getting a 1 and a 1. So the chances of rolling a 2 are 1 out of 36, which is why we want to avoid that when we play roller derby. That's going to conclude the video. If you still need more help, please feel free to ask Mr. Miller or anybody else for help and get your questions answered.